Hello. We are going to talk for a few minutes about how we go about establishing the congruency between triangles. So we learned early on in chapter 3 that if you can prove that all three angles of triangle ABC are congruent to all three angles of triangle PQR, so A is congruent to P, B is congruent to Q, and C is congruent to R. You've taken a nice step towards congruency, but you need a little more. You need to prove that line segment AB is congruent to line segment PQ. You need to prove that line segment AC is congruent to line segment PR. And you need to prove that line segment BC is congruent to line segment QR. If you prove that all three angles from one triangle are congruent to all three angles in the other triangle, and you prove that all three sides of one triangle are congruent to all three sides of the other triangle, then you can state quite definitively that those are congruent triangles. The problem with all of this is that this makes geometry students very sad and weep crocodile tears in their unhappiness. Why? Because this would take forever. We use a bazillion triangles in geometry, and if we had to go through proving every single angle and every single side for every single triangle that we were trying to prove was congruent to another, we would be very frustrated, and we would be sad, and we would probably even hate geometry. And that, my friends, would be a tragedy. So, a very smart guy a long time ago, his name was Euclid, he was kind of like the master of geometry. And he said, you know what, we don't actually have to prove all of this stuff. I mean, if we can prove all that stuff, that's totally awesome. But we could probably narrow this down into like a few things that we have to prove and speed the whole process up. So the first way that you can prove that two triangles are congruent to each other is by using the SSS principle. That stands for side, side, side. It's actually not called a principle. It's called a postulate. The SSS postulate. And what the SSS says is that if you know what all three sides of this triangle are, and if they match the corresponding sides on this triangle, then you can stop and you can say for sure that those triangles are congruent. So for instance, if I have this green piece of triangle, and if I have this pink piece of triangle, and if it is connected by this orange piece of triangle, let's see if I can get this to make a triangle. Yes, I did it. So what the SSS says is that if I have three more sides that are the same length, so I have another pink length, I have another green length, and I have another orange length, that there's only one way to put these together. And that is to put them together in a way that it is congruent to the first triangle. They have to be congruent because the three sides are congruent. That's what the SSS postulate says. Now, there's another thing that you can do, and you can prove the SAS postulate. That stands for side, angle, side. Please notice that it has to be the angle that's in between the two sides that you know. So for instance, if I had, let's say that I knew that this was a 10, and I knew that this was a 3. And I know that this angle right here is, let's say, 100 degrees, right? That is set in stone. And the other triangle, if it has a 10 and a 3 connected by 100 degrees, you're golden. You're done. Because no matter how we draw this 10 and this 3, let's see, how do we have to do this? This would be kind of like this, right? Yep. So this is a 10, and this is a 3, and this is a 100. Then when I draw my third line, that side is going to be congruent to that side, and the two angles are congruent. You can see that I've rotated them, but that doesn't matter. I could flip them around and put them on top of each other, and they would exactly match. Assuming, of course, I drew them perfectly to scale, which I'm sure I did not, so use your imagination. Okay, the third way that you can prove that two triangles are congruent is the ASA postulate, which means that you have an angle, you have a side, and then you have the angle on the other side. So, for instance, if I drew this line and I said that that was 10, and I drew this line and I said that that was 10, if I knew that I was going to draw a 45-degree angle right here, and I knew that I was going to draw a 45-degree angle here, so I know the angle, the side, and the angle. I know the angle, the side, and the angle, and that's congruent to what my second triangle has. Then when I wind up finishing this drawing, these triangles will be congruent. I don't have to measure these other two sides. I don't have to measure that last angle. If I know an A, an S, an A, and they're in that order, the angle that touches the side that touches the angle, then that's enough to prove congruency. So I, for one, am very thankful that Euclid went through all of this and proved it. He was a good dude, Euclid. And you can even read his book. It's kind of old-fashioned, but quite popular, really, among the mathematical crowd. Okay, I hope this helps you. These are the ways that you can establish congruency among triangles.